Hey everyone, welcome back. Today's day 5 of my 30-day FAANG grind, and I'm solving 6 recurring LeetCode problems daily, breaking each down on video and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was on statistics and machine learning. Currently, I'm at top 0.3 on LeetCode, and like most of you, even I enjoy learning LeetCode. Over the last few days, we have tackled problems based on sliding window, two pointers, prefix and suffix based problems, and problems based on strings. Today, we will be tackling stacks and we'll be solving problems based on monotonic stacks, next greater or smaller elements, and problems of such natures. These problems will teach us the structure, flow, and how to handle state across elements, which is a key in interviews. Before I begin, if this video helps you, please drop a like and please consider subscribing to my channel. You can also share my video with your friends. Yeah, and let's go. So today we'll be dealing with LeetCode 496, which is next greater element 1. There is another problem, next greater element 2, and we'll be tackling that after we have tackled this problem. The description of this problem, to be very clear, is kind of vague. So I will directly jump to the dashboard and I will try to explain what this problem expects from us. Before I do that, let us walk through the constraints, which is over here, as you can see. And these are the examples and the description, which again is little vague, not properly described. Okay. So let us go to the LeetCode dashboard and we'll try to solve and investigate this problem in an optimal manner. So in this problem, it says that we have been given two arrays integer array nums1 and nums2, which are this one, nums1 and nums2. And then it asks us to return an array answer of length nums1 such that answer I is the next greater element as described above. So this is the answer I array. This is the answer array that we have to return. And what is described above this part? Let us go through this paragraph, which might sound pretty confusing. Okay. So what this paragraph basically states is that we have to find next greater element in nums1 such that every single element that we are trying to find the next greater element for must also exist in nums2. In other words, it states that nums1 is a subset of nums2, cool, and every time, suppose I have to find the next greater element of 4, which is present in nums1, I'll come to nums2, and in this nums2, I'll find the next greater element of 4. In other words, or basically in a reverse manner, you can say, if I have to find next greater element of 1, I have to make sure that 1 is also present in nums1 and 1 is present. If I have to find next greater element of 3, I have to make sure that 3 is also present in nums1, which is not the case. So we will not be able to find the next greater element for 3. But if I have to find for 2, 4 and 2, we must make sure that these two are also present in nums1. And in fact, they are. 4 is present over there and 2 is present over there. So what does mean? It means for every single element that we have to find the next greater element for, I have to make sure that they also exist in nums1. And since we will only limit ourselves to all those elements that are only present in nums1, our answer array length will also be limited by the length of the array nums1. Okay. And if you look at it from different perspective, for example, if I am at 4, next greater element of 4 in nums2 is nothing. So in that case, we'll just replace it with -1. If I'm at 1, next greater element of 1 in nums2 is 3. Immediate next greater element, to be precise. And next greater element for 2 is nothing, right? In that case, it will be -1. So we will not be making a scan from nums1 to nums2. Instead, we'll be making a scan from nums2 to nums1. Okay. As in, if I am standing at any arbitrary point in nums2, I will ask myself, is that element also present in nums1? If and only if it is present, only then we proceed further to find the next greater element for that element in nums2. Okay, cool. How will we approach this problem? In order to approach this problem, like let us ask ourselves one basic questions. What will be an optimized and an efficient way to determine if any of these elements are present in nums1 and maybe at what index? one of the ways will be to use dictionary or hash map, correct? So that is what I have done here. I've initialized values of nums1 with these pair values, nums and index. So this is the structure of our dictionary, which is this one, right? So 4 is at index 0, 1 is at index 1, 2 is at index 2. In such a manner, I have initialized it, okay? Now, this is my answer array, and initially it is empty. I will just try to walk you through it and see how it gets filled, okay? So first of all, I'm at this place. I ask, hey, is 1 present in nums1? And the answer is yes, 1 is present in nums1. Then what I do, I go on to scan the next data element of 1. And what would it be? It would be 3, correct? So I ask myself, hey, I know that 1 is present and the next data element of 1 is 3, but I don't really know right now where was 1 present in nums1 at what index. So in order to fetch the index, I would ask the dictionary, hey, dictionary, do you have nums1? As in, do you have 1? The dictionary will say, yeah, 1. I have that 1. And it is at index 1, okay? So what do? At index 1, I mark 3. Cool. Now I am at index 2, which is pointing to value 3. Instead of asking the array, I will just ask dictionary, hey, do you have 3? We do not have 3 as a key, right? So I'll move to the next index, and then I'll ask dictionary, hey, dictionary, do you have 4? The dictionary is, yeah, I have 4, which is at index 0, means at this place. Once I have confirmed that, I will try to find the next data element for 4. And in this case, the next data element of 4 is nothing. We cannot find that, right? So we'll mark that as -1. It will move to the next pointer now, the next index, and then we'll ask the dictionary once again, hey, do you have 2? Dictionary is like, yeah, I have 2, and it is at index 2, which is this point. But do we have the next data element for 2? And the answer is no. So in that case, it will be filled with -1. So as now, as you can see now, it is -1, 3, -1, which resembles our exact output, okay? So I hope you understood the basic premise of how this is getting solved. Let me walk you through the brute force approach for this problem. First of all, I'll be declaring a dictionary, which will have nums and index as a key value pair. And then I will scan nums1, and then I'll fill this dictionary, okay? The second thing that I will scan is the result. The second thing that I will create is the result array. And initially, I'll fill all the values of the result array with -1, which will span across the length of the nums1, okay? Then I will scan every element of nums2. And as I'm doing that, I'm asking within this loop, hey, if nums2, if it is not present in the dictionary, what does the dictionary contain? By the way, dictionary contain all the elements present in nums1. I'm asking, hey, if that element of nums2, if it is not present in dictionary, in other words, if it is not present in nums1, in that case, we do not find the next greater element for such an element. And in that case, we just continue this loop once again, okay? But if that is not the case, then what do? We scan from the next index till the last index of the nums2. And while we do so, we try to find the next greater element using this basic condition, which is if nums2 of j, if it is greater than nums2 of I, nums2 of I was the previous element, the current element, okay? And we started scanning from the next element, from I plus 1, right? So if nums2 of j is something that we encountered later in the future, and nums2 of I was present over there, right? So if nums2 of j, if it is greater than nums2 of I, in that case, what do? I go to the dictionary, and from dictionary, I fetch the index of nums2 of I, which I'm pretty sure is present in the dictionary, because if it would not have been present, you would have started to loop again from this instant, right? But since this condition was false, it means nums2 of I was present. And from the dictionary, I fetch the index of nums2 of I, and in the result array, at the index I dx, we replace that value of -1 with nums2 of j. And after we do that, we put the break within this loop, okay? And then our outer loop will start to run once again. And once we have exhausted the entire loop, out of this loop, we will return result, okay? So the time complexity of this thing will be order of n times order of some factor. Order of n because of this outer loop. Order of some factor is because of this inner loop. Order of this factor will be very close to linear. So this will revolve somewhere around quadratic time complexity, okay? And the space complexity is order of n with all of these two spaces that we're taking. Okay. Now let us talk about method two. Method two builds upon method one, which is this, and it deals with monotonic stack. In monotonic stack, as we had discussed earlier today, primarily in this question, in this method, we will be dealing with monotonic, monotonic decreasing stack. Okay, monotonic decreasing stack. All right. So what does it mean? It means in our stack, we will be assembling or pushing the elements as long as it is possible, unless and until the current element that we are at, if it is greater than the top of the element, in that case, we will not push this element. Instead, we will start to pop out top of the element as long as this outer element remains greater. And while we are popping out from the stack, we will be fetching every index of that element which is getting popped out, and we will assign the value of the current element in the result to that index, because this outer element will be the next greater element for that element. It should be obvious, correct? Because that is how monotonic stack works. I will repeat once again. In our monotonic stack, I'll be assembling or pushing all those elements as long as it is possible until I encounter an element which is greater than all of those elements, correct? In that case, I'll keep on popping the elements out of the stack, and while popping, I'll also fetch their index from the dictionary that I have contained, okay? This dictionary, right? And I'll fetch the index, and then once that index is fetched, in the result array at that index, I publish the value of this outer element, okay? Which is exactly what is getting done over here. We scan through the entire length of the nums2 array, and we ask ourselves, by the way, these are the basic things that we declare, okay? A stack, a dictionary as above, and the result as above, okay? We scan the entire nums2, and as long as we are scanning, we ask the question, hey, as long as my stack exists, and if the current element that I'm looking at, which is coming from over here, if the current element that I'm looking at, if it is greater than the top of the stack, then please pop the top of the stack, which is what we did over here, fetch its index from the dictionary, which is what we are doing over here, fetching the index, okay? And once the index is fetched in the result array, at that specific index, please add that outer element, which is what we are exactly doing over here. Once we encounter an outer element which is greater than the top of the stack, we fetch the element from the top of the stack, find its index, go to the result array at that index, and then replace -1 with the outer value. Correct? Once you break out of this while loop, we ask ourselves a question, hey, if nums2 of I, hey, the current element that I'm looking at, is it also present in the dictionary? There's an error here. Let me fix that first. Take a minor error. Okay. I'm asking, hey, the current element that I'm looking at, is it also present in the dictionary? In other words, it is asking, hey, the current element that I'm looking at, is it also present in nums1? Why? Because dictionary contains all those elements that are present in nums1, okay? If that element is present in dictionary, then please add that element to the stack, okay? Because we only want to find the next little element of all such elements which are present in nums1, okay? And once our entire loop is exhausted, we come out of it and return the answer as result, okay? So the time complexity of this thing will be order of n because of this outer loop, and order of some factor which you can estimate, which is coming from this while loop. And this complexity will be because of the stack and dictionary and this result array. Cool. So yeah, this was a really interesting problem. Although it was labeled as easy, but again, it took us a lot of thinking, correct? And a lot of intuition as well. I hope you understood what I was trying to explain. Let us go to the LeetCode dashboard and we'll try to submit both of these solutions, okay? First I will be submitting the brute force one. So I have already copied and pasted my answer. So this is the brute force one, okay? And let us run this. As you can see, it takes a quadratic time complexity, and it does get accepted. Okay, cool. And the next one is a little optimized one. Let me run this as well. And as you can see, this will also be accepted and the test cases have been passed. Correct. Okay, cool. Now let us move to the next part of this problem, which is next greater element 2. But before I do that, if you have any doubt for this problem, please ask me in the comment section and I will try to address that. I will see you in the next part